Tectonics. Today's lesson is all about how the Earth moves and creates awesome structures. So why isn't the world completely smooth like a ball? Take a moment, pause the video, and brainstorm on your graphic organizer why you feel the Earth isn't completely smooth. All over the Earth we have hills, valleys, mountain ranges. How did they get there? And volcanoes, the spilling of lava out of the center of the Earth. Pangaea. Pangaea was a supercontinent. At one time, 200 million years ago, the Earth was one large supercontinent. But how did we end up with the continents where they are today? Wegener was a very important geophysicist. He said the only possible way that the continents were where they are today is by continental drift. All the Earth's land masses were in constant movement, and 300 million years ago they collided into Pangaea. However, 200 million years ago they started to split up. And who's Wilson? Well, Wilson expanded on Wegener's ideas. Wegener couldn't explain why or how they were moving, he just knew they were. Wilson decided that the continents were on large plates or crust sections that were moving. When I talk about plates, it's not the kind that are on your dinner table. It's actually sections of the surface of the Earth that are in movement. And this is called plate tectonics. So how are the mountains and the valleys created? From what you have just learned, pause the video once again, brainstorm and jot down some ideas. The plates are crashing together and spreading apart. That's how! There are three important types of plate movement that you need to be aware of. The first is divergent plate boundaries. This is when plates move in opposite directions, and this can occur at the mid-Atlantic ridge. It is a place where two or more plates meet up in the middle of the Atlantic Ocean, and spreading occurs. Let's take a look how.
At divergent margins, lithospheric plates move in opposite directions. The plates, which include crust and part of the upper mantle, ride over the asthenosphere. As hot mantle rock rises to shallow depths, it begins to melt due to lowered pressure. This forms magma.
The second type is a convergent plate boundary, and this is when two plates come together. Now typically it's going to be between an oceanic and a continental plate, but it doesn't have to be. It could be between two oceanic or two continental or a combination of both.
In a subduction zone, the thinner yet denser oceanic plate dives beneath the continental plate. The continental plate is locked to the subducting plate by immense friction along the shallow portion of a vast sloping fault surface. GPS data for many subduction zones show that the friction indeed causes the leading edge of the overlying plate to be forced backwards. During subduction, the thin layer on top of the oceanic plate is scraped off and forms a wedge at the front of the continental plate. The continental plate deforms in response to the stress. The plates can lock for hundreds of years until frictional stress is overcome in a process called elastic rebound. This can produce magnitude 8 to magnitude 9 great earthquakes. Tsunamis occur when the ground beneath the ocean is displaced, as it does in the simplified animation. This cycle of locking and building stress, followed by catastrophic release, repeats every few hundred years.
Convergent plate boundaries are special because they have subduction zones. This is when one of the crusts are actually pulled downwards, and as it gets pulled downwards, it starts to melt. That magma returns to the surface and creates volcanoes in a lot of cases. The west coast of Canada is a very good example of a subduction zone. In subduction zone, the movement might be very, very slow, and it might get stuck. And this is where we run into problems with earthquakes. We hope that there won't be a major earthquake soon on the west coast, but that's not what the scientists are telling us.
Is a rather big earthquake that just happened off Haida, Hawaii. It's a 3.4, just happened an hour ago.
Thousands are recorded, captured with the seismograph, and translated into these waves. But while the needle moves, the Earth rarely does.
Most of these aren't even felt. Every once in a while, there's a big one that gets felt. The last major earthquake in Canada was in October off Haida Gwaii.
And the aftershocks keep coming.
This is just the last month of earthquakes.
They're off the coast, but outside the subduction zone, far from the big one scientists are preparing for.
We're expecting a magnitude 9. We're expecting minutes of shaking. It's going to be a very different thing.
It's known as a megathrust earthquake, and according to a new study, there have been 22 in the past 11,000 years. Using sediment collected in Effingham Inlet, researchers have been able to date the events.
Encased in plastic is a sample of the sediments, and where these very fine sediments are disrupted, we can identify that we probably had megathrust and/or large earthquake events.
And it's precise. The last one dates back to 9 o'clock at night, January 26th, in the year 1700. Now the question is when the next will hit.
The longest time between major earthquakes on our coast is about 1,000 years. And we know we had one 300 years ago. So the answer to that question is we could have a megathrust earthquake either tomorrow or 700 years from now. So studies such as this are informing our building codes so that our schools and our bridges and our pipeline systems become more and more resilient to these major earthquake events.
And so the work continues.
This is Station 133. I bet this is from Nootka Sound.
With samples stored here for testing in the lab.
Right here we have a very rapid increase and a gradual decrease, which is totally typical of one of these events.
Every reading from the past helps predict what will happen in the future, but the research has its limits.
We don't have the science to actually say when it's going to happen. We just can give you a probability.
Kylie Stanton, Global News, Victoria.
The last type of plate boundary is the transformation plate boundary, and a very good example of this is in the San Andreas Fault in California. In this movement, we only get the movement sideways, so we had the two plates sitting side by side and they move backwards and forwards along each other. This is my reference of the location where I found most of my educational videos on this topic. If you'd like to check it out, you can see more on this topic.